This conference will now be recorded.
So from yesterday onwards, you guys are asking about exam. Okay. Actually, we have every day 2 hour session. In the 2 hours, 1 hour we are going to discuss if I dynamic DMU kinematics is completed now. So today, if it is completed now, only today, tomorrow we can directly clear your doubts, whatever regarding entire programming, and you can start your class. I mean exam. Okay. So or else if there is still some tools left. Okay, after today's class, then we are going to discuss remaining tools tomorrow, and then we are going to start your exam. Okay, so that's why I cannot tell you how exactly at what time it is going to start. Okay, and one more thing is, it is you. Some of you asking about is the exam is 2 hours. It is not 2 hours, only 1 hour. Okay, to simply say, multiple choice questions are there. So it will be asking about all the tools regarding CATIA only. Okay, so in there only 60 bits are there. So each bit carries one mark. Okay, 60 bits, 60 minutes time. That is nothing but 1 hour. Okay, next. So I think it is enough for the exam information. So I think I need to post the link again. Some of them asking about link. Right. So today onwards we are going. Sorry, today not only onwards. On today's class we are going to start our kinematics. Okay. Kinematics is nothing but movable elements. See, these are all the kinematic joint. So before how to open, I will. So it is already recording. No need to worry. So click on start. In the start, before whatever the designing, sketcher or part, assembly or drafting, in only we only enter to the mechanical design. In the mechanical design itself, we have all the tools regarding whatever the requirement of sketcher, drafting and assembly part. Okay, so all the sheet metal, everything will be in the mechanical design itself. But when it comes to the kinematics, we need to go for digital mockup. Okay, digital mockup is nothing but movement. Okay, digitally we are going to move the parts. So in the digital mockup, we have several workbenches. Okay, so in there, what we are going to apply? We are going to apply DMU kinematics. DMU is nothing but digital mockup kinematics. Okay, so click on the digital mockup kinematics. It will be showing like product only. Okay, so we are going to apply our kinematics for an assembly. Okay, so we cannot give any movement for single element. Okay, so now these are all the kinematic joint. So basically, it won't be outside. Here, DMU kinematics toolbar is there now. So in there, you will get in the third option. Just click on them and drag it to outside. So it is nothing but kinematic joints. There are total 17 types of joints are there. See, you can count them. Yeah, total 17 types of joints are there. So in the total 17 tools, so whatever the machine element movement will be, rotation or linear movement or combination of both rotation and linear movement. So every kinematic joint we need to perform on a particular machine component. We can by using these elements, okay, by using these 17 tools, we are going to apply them. Okay, basically they only the 16 tools. Last one is nothing but axis based joint. So based on axis system, we are going to apply the joints. I will explain that in the normal class session. Okay. So like this, we are going to see each and every tool. A total 16 types of joints. Okay, linear or rotational or some kind like that. Total 16 kinds of joints are there. So for using these all joints, we need some elements to apply the joints, and not only for applying joints. After applying joints, we need to show its movement. Okay, so for example, I'm going to apply first one. Okay, so before applying that one, so let's see. So this is not about DMU generic. Next one, this one. Okay, so DMU generic animation is there. So for animation purpose, we are going to use this one, and for the simulation checking, we are going to use this one. Okay, so this is the update button. Position update we don't need to, because we are going to use our assembly constraints. Okay, so I'm going to start with first joint. Okay, so here you can see in the DMA kinematics, you can see that you in the simulation itself, you have simulate with commands or simulate with laws. Okay, I will tell you what is the law and what is the command. Okay, next one mechanism dress up. Next one joints. Next one component fixing. Next one assembly constraint conversion. Next one speed and acceleration. Next mechanism analysis. Okay, first for applying anything, we need to insert some assembled parts. Okay, so I'm go actually have for each and every joint, I already created all the joints. Okay, all the parts and joints I have already created for minimizing the time consumption. So I will apply directly. I'm going to get my parts from the existing part one. Okay, so these are all the 16 joints. For applying 16 joints, I have applied. I created some parts. Next, first one is revolute joint. In the revolute joint, so revolute itself, we are going to we can able to understand what kind of movement we can apply. So revolute itself is rotation. Okay, so I'm going to take revolute joint. So first part I need to insert. So how we are going to insert the part? We need to open it in assemble. See, start, mechanical design, go for assembly design. In the assembly only we can insert the element. So in the revolute joint, I'm going to open the first part.
Lagi ko to siya part.
Observe carefully. Why? Because we need to make sure that every step you are going to exactly you need to follow every step. Okay. So just now I have inserted a part. Okay. See here. So in the assembly, so part one I have inserted. What I need to do, I need to fix the component. So I am going to fix the component by using normal basic constraint. Next, I need to insert one more part. So next, second one, open. Okay. So exactly, it came in its position, right? Without applying any constraint. In the constraints, we only applied one single constraint. It is nothing but fixing. Okay. Now what I am going to do? So I am going to apply this one, this axis and this axis constraint, coincidence constraint I have applied. Okay, so these two are enough to make some constraints. Next one, what I need to do, I need to make that whether I need to make this face to contact with this face, or I can also use offset also. Okay, so even we are not going to use any offset constraints also, there won't be a problem. Okay, we are only applying constraint for making its position. Okay, so we are going to make this rotating object and the holding object in its position. For that condition only we have applied this relations. Okay, so now I'm going to enter to the digital mockup DMA kinematics. Okay, see, now I don't need these constraints. I'm going to delete them. See, now I have completely deleted my, because it is already in its position. So I completely deleted my constraints, whatever we have applied in the assembly. Okay, so now I'm going to apply kinematic joints. Okay, first one, before applying any joint, okay, I need to create a mechanism in the kinematics. Okay, remember, these all the tools belongs to kinematics. Okay, so for applying a kinematic joint, I need to first, basically I need to create a mechanical joint. Okay, go for insert. So here new mechanism is there. Click on new mechanism. So in that new mechanism comes under applications. Okay, in applications, see, this is an empty mechanism. Mechanism 1, degree of freedom. DOF is nothing but degree of freedom. Okay, so degree of freedom 0, because we haven't even applied a single joint. Okay, in between any parts. So first one, joint 1. Next, commands, loss, speed, acceleration. Like this, these are all empty. Just only titles are there. In there is no sub options. Okay, so now I am going to apply my first joint, so which is nothing but this cylindrical washer kind of shape is there now. So it is a fixed component, so I am going to apply. In the DNV kinematics there is a symbol fixed part, so I am going to apply the fixed part. See, in the constraint fix is there, it is applied. Next one, what I am going to do, I am going to apply revolute joint. So I need to rotate this cylinder. Okay, so just click on the revolute joint. So already we have applied mechanism 1. Okay, in that mechanism 1, see, mechanism we can create several mechanisms. Okay, but make sure that whatever the joint we are going to apply, so it should be on either one of the mechanism. It cannot be outside the mechanism, and even it won't be created also. So I have already created mechanism 1. So this is mechanism 1. Next, joint name. Joint name we can rename or we can keep the name itself. Okay. Next one, this are asking about line. This line 1, line 2, plane 1, plane 2 are the inputs for the revolute joint. Okay, so what are the lines and what are the planes? But axial lines. Okay, so I'm going to give the input of axial line for this cylinder. See, part 2, solid 1. Okay, next on line 2, I'm going to select this axis. See, part 1, solid 1. Next, when it comes to planes, I need to select the plane. For example, I'm going to select inside plane. I'm going to rotate the object. So either we can select the planes or the faces. Okay, so on line part 2, solid 1, we have selected line. Now I'm going to part 2, this solid 1, inside face. Next, again rotate to normal. Next, now I'm going to give this plane to as this face. Okay, after giving the reference lines and planes, okay, of two objects which we are going to apply revolute joint, here it will ask null offset. Okay, this null offset is nothing but we have given two faces now. So in between these two faces if we are going to apply some offset. Okay, so null offset is nothing but we are not going to apply any offset. Okay, so in that case, we can use the null offset, or I'm going to use some offset. Actually, in between these two, it has 23 mm distance. Okay, whatever the phases we have selected, in between those two phases, we have 23 mm distance. What I need to do, I can give the distance. So 5 mm I'm going to do. Okay, next one. So I have given the all the details. Click on OK. See, now I have given the joint in the mechanism. So I have given the joint. Joint name is nothing but revolute joint, and the fixed part. Some part is fixed in this joint. Okay, so remember whatever the mechanism you are going to apply. So for example, even you have two links, you are going to move the kinematic joint for a single link. Okay, so for applying any kinematic motion, make sure that one of the component in your mechanism is a fixed one. Okay, so then only you can apply joints for the remaining one. Even a hinge joint is also like the same now. So we are going to fix the some hinge location. So then whatever the link we are going to apply, we are going to apply that link to hinge some kinematic joint. Okay, like that. We in the entire complete mechanism, we need to make sure that single part is a fixed one. Okay, we can decide whether which part we are going to fix. Okay, based on our mechanism. See, now I have given 5 mm offset. Here we have 5 mm offset now. So like this we can make that constraint. Next one. So what I'm going to do here. So we have joints applied. Next command. Command is still not empty. So we haven't even given any command. So we have applied a joint, but we haven't given a revolute command. So how we are going to give the command? Just click on the double click on the revolute joint. In there, we haven't given any in which kinematic motion. Okay, so in here, just click on the angle driven. Okay, you have angle driven now. So we have already given lines and planes. Now what I am going to do? I am going to give angle driven. See, when I gave the angle driven, okay, so I'm giving the angle driven. Click on OK. See, now what is it showing? Information. A box is appearing now. So that the information is nothing but the mechanism can be simulated. So basically, when the a part is fixed and a joint is properly applied, and then you have already given a proper command, so it will inform us that your joint is ready to simulate. Okay, so previously before giving the commands, it is whether we cannot give, our mechanism is not ready for simulation. Okay, now we have given the command of revolute. Okay, we are going to rotate the object in angle. So it is showing that our mechanism is ready to simulate. Okay, click on OK. So now see, so command is there. So in the command one, revolute by angle. Okay, angular rotation we are going to apply. See, now one more thing. So before, if we don't get any previously before applying, so we don't get any information. So in that case, how we are going to check our mechanism is ready or not? Okay, so in the DMU generate, so here first one is simulation. Click on this one, click on OK. See, when you click on simulation, if you got your kinematic simulation mechanism one as well as edit simulation, if you got these two boxes, your mechanism is able to run. See, I'm going to move this cursor like this. Okay, so from the center to only positive direction, a clockwise direction, I'm going to move my object. Okay, I'm going to insert that mechanism, directions, angles, everything. So click on the insert. After click on the insert, okay, directly I'm going to, without changing any modification, I'm going to play the forward. Okay, so now take the key backward. Now play. Are you able to see the modifications? See, once again, I'm taking the key backward. Okay, now the key is here. So now I'm going to play forward. It is already played. Are you able to observe? Why? Because entire rotation has taken in single frame. Okay, in a second, fraction of time it is completed. Now what I am going to do? I am going to decrease the time, rotation of time. See, here we got interpolation steps. In the interpolation step, we can actually, it will be by default one number is there. So whatever the mechanism, whatever the rotation, whatever the linear movement, it will be completed within fraction of seconds. So what we are going to do, we are going to slow down the motion. Okay, so by 0.04 I am going to slow down the motion. Now again I am going to keep the T in here in the from the starting. Now apply the play. See, now it is completed now. Single rotation is completed. Okay, from the again once again I am going to take the key to the from the beginning. So play here. Okay, like this we can play forward, and also here is one more option called play backward. We can also apply play backward. Okay, so like this. Next one, so these are all keys: jump to start, or else step backward. Okay, so or else step forward. Okay, just one by one. So one by one, single angular rotation we can see. Okay, or else next one is jump to end. Okay, this is the end. Next one, these two also the same. So step back, one angular rotation backwards. Next, jump to forward like this. So starting point and ending point are the same. Okay, because we are giving 360 angle. Okay, so here I have given 360 angle. So it is showing that total starting and end point is same. Or else I'm going to see in the command, I'm going to change it. Or else, let me see. So again go for simulation. In the simulation, see, click on the mechanism 1. So we are going to apply our simulation for mechanism 1. So before applying it, delete the simulation view, existing simulation. Previously we have applied, that one is already there. So I'm going to apply. See, now we don't have any simulation. In the mechanism, we don't have any simulation. Now I'm going to click on the simulation. So for I'm generating my simulation for mechanism 1. Alright. So now we got our simulation 2 because we have already applied simulation 1. That one is already deleted. Now I created my simulation 2. Okay. So in here, so by default 0 is my starting. Next I need to rotate up to certain 180. Okay, I can give the limit also here. 270, up to 270 only I'm going to rotate. Okay, this is my 270. Next, click on insert. Okay, from the 0 to 270 clockwise direction I have given my motion, rotational motion. Okay, so now I'm going to decrease the frames. Okay, 0.02. Next, what I'm going to do, so it's already in the endpoint. Key notation is already in the endpoint. So see, jump to start. I'm going to click on jump to start. So we can either move our key by using cursor, or else we can give this keyboard. I mean this key. Click on this key, jump to start. It will automatically start go to beginning. Okay, rotation beginning. We have we have rotated to beginning. Now what I'm going to do, so playback. So, okay, it is already in the start. So I'm going to play forward. Okay, I can stop this and also I can play back, or else I'm going to again play forward or else jump to end. Okay, based on our requirement we can see that. But in all the rotations, okay, see, only a single rotation is there. Now what I need to do, I don't want to stop at a point. Okay, I want to move forward as well as the move backward until I stop. Okay, continuously I need to see the definition of this particular joint. See, here we have an option. So change to loop mode. Okay, basically by default a single arrow will be there, a rectangular box and a single arrow will be there. It is nothing but only single rotation, whatever the direction. So in the kinematic simulation, whatever the angular rotation degree from the starting point to limit, whatever the key we have given, so that is the total loop. Okay, so now what I'm single rotation, it will be completed. So is I'm going to change this single rotation to loop. See, these two arrow mark in opposite direction. That is nothing but it will be forward play as well as the backward play. See, click on this one. It won't be stopping now. So now one rotation is completed. Now it is going backward. Loop condition. Okay, forward as well as after completion of a forward, it will come to backward. Okay, it will continuously playing. So now I am going to stop it. Okay, now it is stopped. Or else we can see one more rotation, one more loop, which is nothing but only forward motion instead of a backward, only forward motion continuously. When the rotation is completed at 270 degrees, so it will automatically again start from the zero. Okay, so once again click on the change loop mode. So now the two arrow marks in known same direction. Okay, now play. So now it is in forward direction now. So now the endpoint, when the endpoint comes, it will automatically again go for 0 point starting. Okay, see, endpoint, now it is entered to the starting. So like this, you only one direction rotate loop mode is also there. Okay, like this we can create. And also, so see, I'm going I'm going to click on OK. Now my simulation is completed. For example, okay, so instead of creating every time simulation, I can create my replay. Okay, in the DMS generic mode. So this is our normal basic simulation. So every time I need to give the simulation and I need to insert it and I need to give uh, motion. Okay, so instead of creating like that, so in here we have option called replay. We can give the simulation to play mode. Okay, here called compile simulation. Okay, so here we are going to generate a replay. Okay, basically we are going to see when I selected a compile simulation, we are going to generate a replay. So here, so just if I directly give OK, okay, it is already created a replay. So I can directly give the motion. Okay, decrease the time. I'm making it in a loop. See, too fast now. So stop it. Wait. Okay, it is increasing the time, but instead of giving decreasing. Okay, so now like this we can play this one. Next one, so it can only be played in the software. Replay also it can only be played and applicable for the software. For example, I need to show to some other. I need to present it to in a seminar. Okay, in the seminar we don't get to open the entire CATIA software and we cannot play the animation, right? So in that case, we can generate the animation video. Okay, so just go for the same application ma. So ikkada compile simulation, click on compile simulation. So here by default generate a replay is there. So instead of generating a replay, I want to create generate an animation file. Select this one. Okay, so this is the WFD code. Next, I need to give a file name where I need to save my file. But that video file where exactly you are going to save. So let's select the desktop. Here I'm going to give animation. Okay, save. See, it will take some time. Before giving it, give the time also. So if you haven't given the time, within a fraction of second, your animation will be completed. Okay, click on OK. So I have given slowest time as possible as slow. I have given it. It will convert it. The animation only creates one single loop mark. Okay, now it is completed. See, so this is the file. So I am going to open it by VLC media player. Okay, like that we are going to play. See, entire rotation, complete rotation, like this. Okay, now it is clear now how to apply revolute joint and how to convert that joint to a simulation and how to record the simulation to normal video form. This is now clear now. Now for the remaining joints, I'm not going to explain how to create this video everything. So for every joint, I'm going to create the parts and I'm going to apply the joints and apply the simulation. Okay, so I'm not going to again show how to play the video. Okay, now I'm going to open file. So next one, Prismatic Joint. I'm directly opening the product mark. Okay, it contains already we have applied the mechanism. I'm going to delete the mechanism. Okay, so I deleted it. There is no application, there is no constraint. Everything is empty, but the parts are in its position. Okay, so now I'm going to apply in the kinematic joint. Second joint is called prismatic joint. Okay, this prismatic joint is nothing but a linear motion of the object on other surface. Okay, see, I have So this is a triangular shaped shaft. So which I need to move along this block. Select the prismatic joint. So here we haven't given any mechanism. We haven't created a mechanism. So it is asking about which mechanism, in which mechanism you are applying the joint. So I don't have any mechanism. So I am creating a new mechanism. So new mechanism is created. We can give the name or else click on OK. Okay. Next one, it is asking line 1, line 2 and plane 1, plane 2. Previously, in the revolute joint, we have given line 1, line 2 and plane 1, plane 2. Those are for rotation. Okay, line 1, line 2 is for that joint. Line 1, line 2 is nothing but the axis. So in which center axis we need to rotate the object. Like this we have given. Now when it comes to prismatic joint, so line 1, line 2, plane 1, plane 2 is nothing but along which line is the reference you are going to move and along which face you are going to take the reference as. So now I am going to hide one of the part. Okay. First part I have hidden. Just select the edge. This is my line 1. Next, go to visible swap visible space. So in here, rotate the object. So previously we have selected an edge, na? So that edge should be aligned with this edge. So these two edges should be coincident together. So now I have selected line 1 and line 2. Now it is asking plane 1 and plane 2. So we need to give the planes also reference. Okay. So this plane and again rotate this object. So this is the face which is going to connect with the another one. So command also we can give in the joint itself. Okay, prismatic joint only for length, linear motion. So I am giving my command here itself. Click on OK. See, now I'm going to unhide this object. Okay, see in the mechanism we have applied and joints, but still I'm going to click on simulation. See, click on the mechanism one, click on OK. What is the problem? Did I get any kinematic joint tool? Only edit simulation is there. Okay, so if you got only one single box, it means that some of the in your mechanism something is missing. Okay, see. So here select the simulation with command. In here, so it is showing that add a fixed part. Okay, for mechanism 1, so this mechanism cannot be simulated. If you want to simulate it, add a fixed part. Okay, so it is asking about add a fixed part. I am going to fix the block. Okay, it is showing it can be simulated. Now once again I am going to simulate with the command. See, so I can insert the kinematic simulation. Okay, and also I can simulate it. Now go for simulation, mechanism 1, apply, just give the simulation direction. Okay, I rotated the object. So now it is in the like this. Okay, so I need to give my limits. So click on the three dots. Okay, so for example, we don't know exact distance between this face to this face. So lowest value it is 100. Okay, so for example, let's see. I'm going to drag it outside. So lowest value is applying to in this direction. Okay, so now I'm going to apply in positive direction. It is also going inside. Okay, approximately I am going to see. So up to here only I need to move. So this value is nothing but 60. Okay, so next one. in the opposite direction also up to here. Okay, in both direction positive 60 and negative 60. I'm going to give the values. Minus 60 is the lowest value and highest value as 60. Okay, in linear movement also I'm giving the limits in between which limit it need to be created. Okay, like this. So from here to here I need to move this side. I need to give full rotation. Now I'm going to insert. Okay, so I have inserted the kinematic simulation mechanism to simulation mode. Now every tool is active. I'm decreasing the frames. Now I'm going to apply the play. See? Okay, so like this once again. So in the both direction we can move because we have given the limits now minus 60 and 60 like this. Or else instead of giving minus 60 and 60, I'm giving previous minus 100 and 100. Okay, or else okay, so the body itself is like this, huh? So in the joint I'm giving some offset or like that. So we don't have any offset. So here itself we can give the limits, joint limits. Okay, so direction is also showing up. See, when you select go for this arrow mark, it will directly show the movement. Okay, like this. For example, I need to make sure that this object is aligned with this one. How I'm going to make that one? So we have planar alignment here. Planar joint is there. This joint is going to align with this joint. Click on OK. Okay. So now what is it showing? Too many joints. See, at least one command parameter is out of its simulation. Why? Because we have given prismatic joint and also we have given planar joint. Planar joint will restrict the planes to move. Okay, I have given these two planes. What happens? These two planes cannot be moved from one another. So I am going to delete this one. Okay, now I am going to see if I can give the simulation. See, now the result. Okay, go for mechanism analysis. So if here you can check whether your mechanism is ready to simulate or not. So mechanism name 1, mechanism can be simulated, yes, and the number of joints 1, number of commands 1, next degrees of freedom 1. Okay, so degrees of freedom 1, why it is now degrees of freedom 1? We have given linear motion, only 1 degree of freedom is there. Next, degree of freedom with command, it should be make sure that it is 0. Okay, if it is not 0, you won't be able to simulate the object. Okay, next one. After checking the mechanism, go for simulation. So now what I need to, so minus 60 is there, I need to move the object to here. Okay, we can give, we already given the limits. So or else we can give in the second limit minus 60 is there now. So I am going to increase the limit. So I don't want to stop up to here. I need to completely move this object to here. what I'm going to do, I'm going to give 200. Okay, second limit at 200. So here I'm going to click on reset. So this is my starting point here. So I'm going to give complete 200 up to here. Click on insert, just decrease the frames. Now play. So it will come up to where we have given. So like that we have completed minus 200 distance, it will come outside. So we can also make it in a loop and play it. So both forward and backward. See? So I increase the speed of the movement. Okay. Assembly animation, we can make that one more. Okay. So here we are only applying joints for, we are only seeing how to apply joints for two elements. Okay. But in next tools, I am going to use more than one joint. So then you are able to see. Okay. So this is only prismatic joint. I only applied one joint. So next one is also the same, cylindrical joint. But when it comes to cylindrical joint, you can apply either one of the command. Like you can either move your object in linear motion, or else you can move the object in angular motion. So see, I'm going to close this one. Now go for open. Here cylindrical joint is there. Click on open. So this is my cylindrical joint. Previously what we have done for this similar kind of two elements, we have applied revolute joint. In the revolute joint, we are only able to get only angular rotation only. Okay. So here we can also see in the joint command, we can give the rotation and angular as well as the length. Okay. So I'm going to delete this particular mechanism. Click on OK. See, everything is now clear. Now I am going to apply fix for a new mechanism. So this is the part I am going to fix. Okay. Next, I am going to apply cylindrical joint. Go for cylindrical joint. In the cylindrical joint, it is the simplest joint. It doesn't ask for planes. Okay. Only along which line it is need to be applying cylindrical joint. So along which line axis. So I am going to give the center axis as well as the center axis here. Okay. In here, we can give the angle given. Click on OK. Okay. Now what have done? Only angle given I have selected. Go for again select the length given. So both angular length. Okay. Now it is simulated. See, go for simulation. Click on OK. See, now we have two commands. Previously, in revolute joint, you only got angular look, and when it comes to prismatic, you only got one single linear motion, length. Okay. When it comes to cylindrical, you can apply both angular as well as the cylindrical. See, the first one is command one is nothing but angled. So it is asking the angle between minus 360 and 360, clockwise and anti-clockwise. So I am giving total 360 degrees in a clockwise direction. Okay. Next one. So command 2, it is asking about length. Okay. So I don't know exact length of this one. So I'm just directly moving it. See, when I'm moving in a positive direction, it is giving a, it is going inside. but we don't need inside. So I'm going to click on the reset. So click on the positive direction and give it in a negative direction. Linear direction, negative. Like this. Up to here it is enough. So click on insert. I'm going to insert these two commands in the simulation. Now make it in a loop and give the frames low. Now play. Okay, like this. When it is rotating, along with the rotation, this linear motion will also be applied. Both commands at a time. Okay, like this. Next, are you able to clear, ma? Are you able to understand? So the revolver joint is only for one single rotation. Okay, only rotation purpose. Next, when it comes to prismatic, only for single linear length driven. Next, when it comes to cylindrical joint, you can, along with the angular movement, you can also apply your length. Okay. Next one, screw joint. Screw joint, we can apply either one. Okay. So I am applying my screw joint for this one. So in this bolt or nut, I can fix either one. Okay. I can fix the bolt and rotate the nut. Okay. Or else I can fix the nut and rotate the bolt. Either way. So see, before giving any application, here you can see command is only one command. Okay. Now I cleared the entire mechanism. So insert. See, for getting threads, you need to make sure that you are going to remove the material. Okay, you have operation, slot operation now. So you can apply that slot. This is my mechanism. Now I need to apply, fix a part. I'm going to fix this nut. Okay. Next one, I need to give a joint. Go for screw joint. So in the screw joint also, we only need to give axis, center axis. So for this one, I'm going to give center axis. And second center axis is just hide this first part. For easy purpose, I'm hiding the first part. Rotate this one and give the center axis. Okay. So the next one, I'm unhiding this one. Okay. See, it is asking angle driven. Okay, so now I'm giving angle given and it is also giving pitch 1. Okay, see, without changing the pitch 1, I'm going to click on OK. See, mechanism can be simulated. Okay, remember, I haven't changed my pitch and it is only one pitch. I mean, only one rotation like that. So I'm going to apply simulation. Here, just give the rotation, insert. Now decrease the frames, play backward. Okay, like this we can apply, or else I'm going to increase the pitch in the screw. I'm going to increase the pitch by 10 or else 20. Okay, so here click on OK. See, go for simulation, mechanism 1, click on OK. So I'm giving, see, when I'm moving, I'm going to make that lowest value is 0 and highest value is 360. Click on OK. Okay, reset. So from 0 to 360 I am going to move. Okay, 360 is not enough, I am going to increase again. Make it as 700. Click on OK. So from here I need to move up to here. Okay, now it is increased enough. So now I am going to insert this motion. Okay, remember we only gave, see in command only we gave only screw angular rotation. Okay, when we increase the pitch, it will take along with the rotation. So we have given 20 pitch. So it will take 20 rotations, like, okay. Next one. Now play. Okay, I have put it in a loop mode. So from the lowest limit to upper limit. So 0 to 700 angle, it will rotate. Or else I need to increase some more. Okay, it is coming on up to here only now. So I am going to increase some more. Give it a 1500. Second limit I have given up. Click on OK. So now reset it and go again. See, up to this end. Okay, I need to insert this mechanism. Now I'm going to play. See, like this we are able to play our mechanism. Okay, this is our screw joint. In this screw joint we have one more option. Okay, instead of angle, what I'm going, we can also give, see, length driven. Okay, so I'm going to take length. Click on OK. Click on OK. Now go for length. So I haven't, now I have taken only length mark. You can say command only length, screw length. See, for 100 to 100 it is taking. So I have already given pitch to, pitch I haven't changed now. So once again, change the pitch back to 0. 20 is there and they're giving it a 1. Okay. Okay, now go for simulation. Let's see. So it won't rotate now. Now it won't rotate. Only linear direction it will show. Okay, I'm going to reset it. -20 and 100 is not enough. 200. See, from here to, okay, 200 is more. So I need to make it as only 83. Okay, so once again, okay, like this. Now I'm going to insert it. Again, once again, reset, insert, decrease the frames, make it in a blue and play it. Okay, like this. So either linear or else either angular. So here we can use in both two commands. We can use one in the screw command, screw joint. Next one, it is nothing but a spherical joint. Spherical joint is a rare application. Okay, so for a spherical ball type of joint, we are going to use. Go for open I have just created a simple spherical. So it contains two parts. Okay, I haven't given any motion mark. For applying a motion, I need to make sure that I need to make another point here. Sorry, another object in here. So I need to make a revolute joint for that. Okay. So here I just applied so we cannot able to see the simulation also. See, only rotation will be there, but it is a simple object now. Wait, just a minute. Directly delete all these things. I'm deleting the simulation also. Ma. The simulation also deleted. Now everything is clear. See, here we have two parts. Okay, I'm moving my object. Okay. So these are the two parts. For applying a spherical joint, make sure that you have spherical body. Okay, two parts. One should be a slotted one, and another should be a body. Okay, so we need to insert this spherical object in here. Okay, so directly go for spherical. Just it is asking the new mechanism. Click on OK. Now I'm going to give point 1 and point 2. This point 1 and point 2 are nothing but center points. So this I'm going to select the center point of the particular sphere. Okay, you can create your center point or else it will defaultly highlight your center of the sphere. Okay, second point belongs to this okay, this box. Click on OK. Okay, so now this completed. Next one, I need to fix a path. I need to click on the fix. So this rectangular block I am going to fix. Okay, now see, I have applied join and fix. Okay, so when it comes to command, there is no command for that one. Okay, so what I am going to do, for example, previously in simulation we have applied rotation, revolute joint. So the same I am going to say apply revolute joint. So here I need to give which part I am going to revolve. Line 1, line 2. So line 1 is nothing but this axis and line 2 is nothing but this vertical line. Next, when it comes to planes, so I am going to give this plane and with respect to this base plane. Okay, so I have given all the inputs. After giving it, I am going to give this angle driven as my command. Click on OK. So command is not taking. Check your joint. It hasn't formed. So once again, form your revolute joint. So spherical joint is only connecting purpose. It doesn't have any motion. Okay, either linear motion, either not nor cylindrical motion. Okay, just it connects the cylindrical shape. So for applying seeing a simulation, we need to apply one more joint, either revolute or screw or cylindrical joint. We need to apply. Okay. So I'm going to once again giving it. Here when you are selecting, make sure that you are selecting different parts. The center plane maybe belongs to both the bodies, part 1 and part 2. Okay. This is the axis. I'm going to hide this part for a better selection. I'm selecting the vertical plane. Next one, I'm going to select this plane and hide this one. this plane. Next, angle given. Over constraint. It is showing that over constraint. Okay. Okay. Instead of revolute joint, I'm going to apply the screw joint. Let's see this. I did this axis, angle given, pitch. I don't want to pitch. So now we have applied a screw joint also. Okay. So we have command. I'm going to unhide this one. So let's see if whether our simulation is able to simulate or not. See, mechanism can be simulated. Yes. Go for simulation. So I'm going to give it a 360 degrees and forward direction. Just decrease the frames. Okay, like this. Okay. And I be giving the instructions very fastly because we only got today. Okay. And tomorrow maybe maximum 1 hour is there. So we need to try to cover all the tools. So now sphere is completed. Next one, planar joint. Planar joint previously I have shown you that two planes. We are going to connect two planes. Nothing more than that. So it doesn't have any kinematic motion. See? So for applying this one, P. Now in this joint, I'm going to apply several joints. Planar joint, I'm going to only use this plane and this plane to be coming together. Okay, for reference purpose. But instead of planar joint, I'm going to use, see, so roll curve joint also there. So I need to rotate this object along this particular cylindrical. Okay, so here, delete this one. Okay, now see, so these two are individual objects. I'm going to delete the constraints also. So line kind contact is there. I'm going to delete this one also. Now everything is clear now. Nothing, no constraint is there, no fixed point is there. So now go for insert mechanism. The mechanism I have inserted. I'm fixing a component. This is my fixed component. Now I'm going to apply planar. So I need to give these two planes, this face and this face to be in alignment. Okay, select this face. Okay, those two faces which I have selected should be in an alignment. Okay, now it is completed. Next one, after giving it, I need to rotate this small cylinder along the inner face. Okay, so we have some curve symbols is there. First one is nothing but point curve joint. So by using point curve joint, we can attach one point on a curve. So I don't want to attach a point, but instead of that one, slide curve joint is there, and then roll curve joint is there. So I can apply either one of these two. Okay, so I'm going to apply roll curve joint. So slide curve joint I have selected. So curve one it is asking zoom the element. First one, second curve is nothing but this curve. You can okay. See, still we don't get any command, any kinematic motion. So I'm going to apply roll curve joint. So in this also same. I'm going to roll this curve along with this element. Okay, here we got our length joint. Click on OK. See, mechanism can be simulated. For this particular mechanism, we have applied 3 joints. Okay, so first one is nothing but planar joint, second one slide curve, and third one is roll curve. Okay, now we can check. See, mechanism can be simulated. Number of joints 3 and number of commands 1, degrees of freedom 1, and the degree of freedom with the command is 0. So it is perfectly, it can be simulated. So remember, when you are moving the key, if you give some stopping here, so the time will be taken inserted. Insert, see, I'm going to make it in a single loop. See, at exactly which point we have taken some time. So wait. Simulation. Okay, so I'm going to insert a new simulation. Mechanism 1. Here, see, I'm dragging this point from here to here. So up to here itself. Now insert it. Playback. Okay, like this. This particular green color cylinder is going to revolve along with this curve. Next one. So we have point curve. By applying these 3 joints, we have no. This rigid joint is there. So see, rigid joint is also there. For rigid joint, I already told you in assembly itself. For example, for entire assembly, you are going to only fix one single component. Okay, you cannot fix more than one. But for some mechanisms, so more than one should be in a static position. So in that case, we are going to apply rigid with respect to fixed one. See, rigid joint is there. So it is simple one more. Just we are going to rigid with respect to one another. It doesn't have any kinematic motion. We have this one. See, black color one is there, grey color one is there. Now I'm going to apply the motion. Okay, I'm going to move it. Now it is moving not individually without implicating one another. It is moving. Now what I am going to do? See, here it is. I am leaving it. It is a sketch. Sorry. So I am going to fix this component. So before fixing, I need to make sure that one of the mechanism is inserted. Mechanism inserted. So now first component I am going to fix it. Okay. So now I have fixed this one. I am going to move the second one. It won't be problem now. So I can move in any direction or I can give any angular rotation also like this. Okay. So now I'm going to make the rigid. Here is the option called rigid now. So I'm making the rigid. So he gives a part. This is the rigid component. And with respect to this component, click on OK. See, now these two are rigid components. if I move one component, it will automatically move with respect to another component. Okay, doesn't have any command. Okay, to simply say these two are a fixed component. Okay, those two doesn't have any motions in this particular workbench. Okay, next, see, after this one, point and curve and as well as the outlines. See, this is a link mark. Bicycle chain is there, na? That kind of links are there. One is interior link and second one is outer link. Okay, we can combine all the remaining links along this lines. See, for example, this is the entire path of the chains. So I need to rotate these two links, outer link and the inner link. So along this particular curves. Okay, so here we have taken two curves for my reference. Okay, so here see we applied both point and curve. See, I'm going to zoom it. Okay, so I think it is clear now. Here I'm going to apply this point on curve and slide curve as well as the roll curve. So all the three curve joints I'm going to apply. Okay, for moving these objects along the line curves of these two. See here in the mechanism, see in the joints, you can see we have applied point curve. Okay, so this point curve belongs to this curve and the point. See, inner link, point, and as well as the curve. Next one, this point curve, second point curve we have given. So inner link point and the outer part. Next, slide curve. Along with this outer profile, we are going to slide. This revolute joint is also there. In between these two links, when it is going to bend, we are going to apply the revolute joint. But remember, so here this point curve is going to now this one. Okay, just if I directly simulate it, you are not going to get how you exactly are going to play this one. So I deleted this constraint mechanisms. So constraints also you can delete it. Okay. Now make sure that your links are in its position. Okay. For getting the position only, we are going to apply the constraint. Okay. So now I'm going to start my joint. First create a mechanism. Now the mechanism is created. Now fix elements. So if these two links are going to be moving, so I need to fix these two spline curves. Okay, so these two spline curves are fixed components. Remaining these two joints are movable, so I cannot fix these two. Next one, so go for point curve joint. Okay, so make sure that you are selecting exact center point. Okay, so it is asking the curve, so this is the curve, and next point it is asking center point, so this is the center point. Click on OK. Okay, now I have given first point. Next one, Again, I'm going to give this point also be aligned with this point. So I'm giving the center point curve. So this point, select the line and also this point, click on OK. Okay. So next also, I need to make sure that this point is also aligned with this one. Okay. Select this one and also this one. Now I have given 3 point curves. See, curve 1, curve 2, curve 3. So 3 point curves I have created along with the 3 joints. And if we have more than these 2 links, we have to give each and every point to be slide on this curve. Okay. Now point curve is clear now. Next one, we are going to apply slide curve joint. Okay. These 2 links need to be slide along the direction of this curve. So in this curve 1, I'm going to select this one, and curve 2 should be attached to this one. Okay, zoom it for selection. So this is the curve. Okay, click on OK. So now it is completed now. Next one. So I have applied my curve also. Along with this curve, I need to revolve in entire rotation, cyclic rotation. Next one, slide curve, roll curve joint. Okay, this roll curve joint, I'm going to roll. I'm going to apply these two. Okay, this is already given now, so no need to give one. Next one. Okay, next one we have to give revolute joint in here, because when the link is going to bend, so we make sure that the outer link should be rotating, bending with the inner link. So I'm going to give revolute joint here. Line 1, just hide this one. Okay, this is the line 1, and go for swap location, swap visible space. This is the line 2. Next, plane 1, plane 2. So normal position. So this is the plane, and second plane, you need to select rotate. This is the plane 2. Okay, click on OK. So now the mechanism is okay. Like this, we have given everything. Let's see. We don't have any command. See, go for mechanism analysis. So can your mechanism be simulated? It is saying no. Your mechanism cannot be simulated. Why? Because we only gave all the joints, but we haven't given any command. See, click on here. See, it is asking add at least one command at a joint. Okay, so at least we need to give one command. So we have given so many joints. What I'm going to do, for I'm selecting the first point and I'm giving length driven. Click on OK. See, command has no effect and the degree of freedom of this mechanism. Okay, let's check the degree of freedom also. See, mechanism and degree of freedom is 0. Now command is also ready. Now I'm going to check my mechanism analysis. See, total number of joints 6, and mechanism can be simulated. Yes. Okay. Next one. Go for simulation. See, I'm going to give is not taking up. Okay, 1 minute. Something is not taking. roll curve joint we have given. Okay. See? So I'm going to increase this one. 822 is stopping at this point now. So I'm going to increase up to here. So I'm going approximately I'm giving 1000. Okay. Reset. $250, 2000. From here I'm going to start. So this is 1000. So up to here it is coming. I'm going to increase some more. 1200. So here too, I need to rotate along the direction. 200 is increasing. I'm going to decrease one more. 1100 only. Once again. So here too, I need to rotate along this direction. It is moving over done. Let's check. It changed it now. It is not changed. Once I'm going to close this, I'm going to open. Change the limit. Now it is changed. Reset. Now apply this one. Okay, up to here. Now it is clear now. So it is taking total rotation. Okay, from the starting to total rotation. So like this we are going to change the limit. Now insert. After inserting, so you can see decrease the frames and make it in a forward loop. Okay, now play. Single loop I am making it. I'm decreasing the time. See, okay. So like this. So the chain link we have given will be rotating along the axis. Okay, whatever the plane we have given curves. So we are going to rotate along the axis. Like this we are going to apply. Okay. Each and every curve joint has its own degree of freedom. Okay, see here we only give in commands for entire we have applied total 5 joints. Okay, but when it comes to command we only applied for only single command. Okay, there are several commands we can give, but if we have given more than one, for example, I have given command as only point curve one. So I'm going to command here also length driven. Click on OK. So what is it saying? Okay, the creation command has no effect on the degree of freedom. Please click on OK or cancel the command. Okay, so if you are going to simulate it now, see, the command is automatically deleted because it doesn't have any effect and it doesn't need to be created. Okay, like that. Even though if you are, if for example, in a revolute joint also, I'm going to give angle driven. Click on OK. See, mechanism, like it won't be creating. Revolute joint, we have given angle driven, but in the command, it is not going to take. Okay, like this, it is basically it is taking whatever the requirement command only we need to do. Even we have given over more than one command, it is going to say it is not, it has no effect on the mechanism. So it will automatically delete some of the commands. Next one, up to this curves is clear. Na? Next one, point curve joint. See, sorry, point on surface. It has more than two parts, so it will take rigid joint also count. See, here, so point on surface we don't need to, yes, this is the joint. So here we have total 4 points, sorry, 4 parts. So first one is a surface. Okay, I haven't told you how to create a surface, but remember this point on surface is belongs to surface. Okay, this one doesn't have any uh, kinematic motion, but we can add, for example, this surface is a bend one. Okay, along this bend, I need to move my this pointer. Okay, and this pointer should be attached to this sharp corner. Okay, so when we are creating that one, we will get the point, and on the surface we need to create a point. Okay, so next one, when it is moving along the curve, so this cylinder should be moving along the curve, and as well as the based on the height, it should be moving along the this particular cylindrical block. And also when the cylinder is moving, this rectangular block which is holding the cylindrical body, it should be moving along this vertical bar. Okay, so then what? So this bar should be a static one. It cannot be moving. Okay, only these are rectangle blue color box and as well as the red color cylinder. These two are the movable objects. Remaining surface and this rectangular long bar is fixed one. See, so we are going to fix only one component, that is nothing but the surface. Okay, with respect to this surface, we are going to fix this long block by using rigid command. See in the command, sorry, joint, we use rigid for this one. Okay, so I'm going to delete this one. Now everything is clear. Constraints also I'm going to delete. Okay, so total 4 parts are there, but it doesn't have any constraints or kinematic joints. Now I'm going to start my mechanism. Go for insert, new mechanism. So here it is a new mechanism. It doesn't have any joints, anything. So first I'm going to start my mechanism with fixed one. So this is my fixed one. This surface is a fixed one mark. Okay. So I have given fixed command. Next one, with this one, I'm going to apply this point on curve. See, point on surface. So click on this one. Here I'm going to give surface. This is my surface and the point. So this is the point. Okay, so we have given point as well as the surface. Click on OK. Okay, basically point on surface doesn't have any kinematic motion, but it will give the uh, alignment. Okay, surface orientation of it, whatever the angle or whatever the twist it has. So it is going to follow. If this point is going to follow this particular curve shape. Okay, now it is completed from this static uh, fixed surface to this point is completed. Next one, what we need to give rotation movement. Okay, so not rotation, linear movement. Okay, we can give the linear movement by this screw one. So go for line one and then hide this object. So this is the line two. So just zoom it. Okay, this is the line two. In between these two, I need to give length driven. Click on OK. So remember, if you are going to give a length driven in here, so it will take more than one command. So I'm not giving any length driven. I'm directly just giving the references. Click on OK. So up to now, we have played two joints and we haven't given any command. Next one. So from this blue color body to this one, we need to give linear motion. For linear motion, we call the joint as prismatic joint. Select the prismatic joint. So first line it is asking, this is the line, and hide this one. Rotate the object. Okay, this is the bottom line. Okay, these two lines we have selected should be connected together. Next one, the faces to be contacted, we need to select. So this face, I'm going to unhide this one. Rotate the object. So this face, these two faces are going to contact. So now I have given both lines and faces. Next one, I am going to select the length driven. Click on OK. Okay, now we have given length driven. See, we have fixed the part and we have given the component. Let's check our simulation. So mechanical can be simulated? No. Okay, why? So let's click a check here. Add a command on the joint. There are not enough commands. Command is one, we have given one command, so it is not enough. I'm going to add more than this command. Here, length driven. Okay, let's see. Okay. Next, I'm going to unhide this one. We have hidden this part now. Okay. Next one, you forgot one more thing. Okay. So we have given command, but main thing is this blue color. Sorry, this long bar is in it. It doesn't have any support. Okay. I'm going to use rigid joint. So this is the part and this is the rigid joint. Click on OK. See, now what is it saying? It has too many commands. I'm going to delete the one. See, now I'm going to check. So now it is ready to simulate. Okay, go for simulation. I'm going to increase this negative value. See, so this is 100 to, sorry, here 150. I need to move my object. Okay, see, this is the lowest point. So cylinder need to be come downwards. Okay, and as well as the cylinder holding rectangle box also need to be move along with the direction. Now I'm going to insert. See, decrease this, apply. plate. See, from here cylinder is not going to come inside. Okay, so when the joint is moving along this direction, cylinder also need to be moving along the linear direction. Okay, like this. Okay, so this is the combination of cylindrical, no sorry, not cylindrical, we have applied a screw joint. Okay, screw joint as well as the point on surface and prismatic rigid, combination of four joints. Okay, like this, when you are going to apply some other kind of mechanism, more than two joints you are going to use, must and should, for applying a simple mechanism also more than two joints are necessary. Okay, based on your selection of assembly, so you are going to apply your joints. Everything is clear, ma? So up to here we have clear. Next one, universal joint. Okay, you have seen your universal couplings, right? So I have created two one universal coupling, basic one more, not even a standard one. Just I created some basic one. Okay, it has total 1, 2, 3, 4, 5 parts. Okay, so these are the 5 parts which are nothing but these two are U-shaped universal coupling. Next one, first one is an axial. Next, these are two collars. Okay, total 5 parts. So after creating this one, I'm going to delete mechanism and simulation. So you all know how the universal coupling is working. So I'm not going to say once again. Directly deleting it. Now it doesn't have any constraints or joints. Okay, I'm going to insert a new mechanism. Okay, so now what I need to make sure that, okay, the force angular rotation of one universal axle is going to transfer in certain angle. So this angle also we need to make that in our assembly map. Okay, I have deleted constraint everything, so it is not showing. So this angle everything we need to make in the assembly itself. Okay, so I have already explained how to make angular constraints. Okay, so I have marked these two like this. Next one, I'm going to, I have only created an empty mechanism. I need to make part fix. Okay, so I'm going to fix, apply the fix. This color I'm going to fix. Okay, so next one, this color is also be, it should be fixed one. Okay, so I cannot use fix for two components, so I'm going to use rigid joint. Okay, so this is the my preference and this is my object to be fixing. Now applied joint called rigid. Okay, now up to here everything is clear. Next one, I need to rotate this one universal joint side. Okay, so I'm going to apply revolute joint. Okay, so in this revolute joint, line 1 it is asking, this is my line 1. Next line 2 is this axis. Next, plane 1 it is asking, rotate the object to select. Okay, this is my plane 1 and outside collar is my plane 2. Now it is given, I'm giving it angle driven. Okay, only for entire this universal joint, only the rotation should be coming from this revolute joint. Okay, so here only I am going to rotate. Along with this angle rotation, I need to see mechanism can be simulated is showing, but we have given proper joints for everything. If we simulate it in here, what will happen? See, I'm going to simulate it. What is happening? So only this fixed joint with respect to fixed joint, this revolute joint is rotating, but this is not the result we did. right? This is not the result we needed. So what I am going to do, I need to transfer my rotations from this particular joint to this joint. Okay, for this one, what I'm going to do, again select a revolute joint. So I'm going to give the revolute, just axis reference I am giving one, but I am not going to give angle given. So plane 1, plane 2 it is asking. This is the plane 1 and this is the plane 2. And remember, when you are selecting, make sure you are selecting the faces instead of the edges or anything. Okay, I'm not going to give any command here. So I directly click on OK. Now second revolution also completed. Now I need to make these two joints. Okay, these two limbs are connected by this axis, plus symbol axis. So I need to connect them by using basic cylindrical joint. Okay, so this is the axis. I'm hiding this one. Now I'm going to select this axis. Okay, click on OK. Remember, I'm not giving any other command. Okay, so next one, unhide this one. Again, cylindrical joint, this axis with respect to this holes. Okay, see, we have given rigid, revolutes as well as cylindrical. Okay, so but we have given only one command revolution. First shaft, it is my first shaft now. So only I have given this shaft as revolution. So my force, okay, from the engine, I'm getting the force for this particular shaft. So I'm going to transfer this rotation to this shaft. Okay. Now apply your simulation. See, it is not moving completely. 8 more. Okay, this part is hidden. Now it is here. Now let's give the simulation. Mechanism 1. It is only moving for certain angle. 0 to 360 total is this I need to do. It is not moving beyond this one. Okay, let's see. I'm deleting this level. I'm undoing this one. Okay. So command I have removed that command. So I'm going to give revolute for this shaft. Here is angle driven. Okay. Now let's see the simulation. We need to rotate it in 360 degrees completely. Zero to 360. Okay, I changed my limits to 0 to 360. Now let's see. Let's insert this one. Instead of 360, it is only rotating for some angle only. Let's give more than this. 0. 0 is not taking. Is the maximum angle rotation. Is 0. It is not changing, but sometimes software will be like this one. So we are not using the software licensed version. Okay, remember, we are just using a normal basic one. So it will, sometimes it will show this kind of problems. Okay, so but it will compulsory. We have given the entire procedure completely correct. Okay, so then only it is able to simulate. But it is not rotating complete 360 degrees. Change the degree. I given 766. See, now it is not even tilting. See, sometimes it will show so this kind of problems now. But whatever the procedure we have followed and whatever the commands they have given, everything is very clear. Procedure, everything is clear. See, let's check 270 less than 360. See, now also see procedure, everything is clear now, but sometimes software will be like that. Okay. Next, CV joint. Okay, it is already time over now. Okay, ma. So universal joint up to here we are going to stop our class.